Hello, my audience. Today we're going to be looking at general gas law. In our previous lessons, we look at Boyle's law, Charles law, pressure law. So today we're looking at the general gas law. And the general gas law states that for a fixed mass of gas, the product of pressure and volume is directly proportional to the absolute temperature. So which means mathematically, for a fixed mass of gas, PV is directly proportional to T, which means PV will be equals to some constant K multiplied by what? T. So here we can divide both sides by T. If you divide here by T, you divide here by T, then that's going to give us PV all over T is going to be T cancels T. I'm left with the constant. That will give us P1 V1 all over T1 equals to what? P2 V2 all over what? T2. So this is what we call yes for that's what we are going to apply for general gas law. So this is the first one. Then by combining maybe if you combine Charles law and pressure law, you will not realize, because in Charles law we realize that volume is directly proportional to temperature. Then in pressure law, pressure is directly proportional to temperature. So since V is directly proportional to T and P is directly proportional to T, that means the product of P and V, which is PV, will still be directly proportional to T. So which means PV can be equals to RT, where R is known as the molar gas constant. Then for N moles of a gas at STP, we are going to get PV equals to nRT. Yes, PV equals to nRT. This will be our second equation. So this equation 1 and equation 2 are called general gas equations. So, and they are being obeyed by perfect gases. But unfortunately, there is no gas that is perfect in real life. The only gas that tries to be perfect is oxygen. But when oxygen reaches its liquefaction temperature, which is minus 83 degrees Celsius, it deviates from the ideal behavior. So let's look at it. Representing it graphically will give us something like this. Plotting a graph of PV against P. It will be parallel to the P-axis. So this is a theoretical concept. We don't have perfect gases in real life. What we have are real gases. And when they come, they'll be deviating from this. You'll be seeing something like this. They'll be deviating from the ideal behavior. So this graph A, B, C, and D. Yes, the one that will be the ideal gas law or the general gas law is A, but it is a theoretical concept. Then R actually is known as the molar gas constant. Molar gas constant. And R can take a value of 0.0821 atmosphere dm cube per mole per Kelvin. Or we can still use R to be 8.3 joules per mole per Kelvin. And so in our next video, we are going to be taking some calculations involving what we call the general gas law or the ideal gas law. Please do press the plus button, comment, and if you have any question, please you drop it on the comment section. Bye.